Hello. Welcome to our webinar today about building your own IoT products, consumer versus enterprise. We've got a great panel today, and hopefully today we're going to be able to give you some beautiful insight into building your own IoT product either for the first time or maybe even evolving one that you've already gotten started or have in the field. So today we've got a great panel. We're going to try not to do a death by PowerPoint. And we're going to focus our discussion predominantly around internet-connected devices. So when we talk about IoT, we're talking about the creation of potentially smart products that you're going to manufacture and put out in the field that are connected and can be connected to the internet. With that said, let's do a little round of introductions. Kevin, why don't you start us off?
Hi, excuse me. Hi, it's Kevin Bailey. I've got 30 years in physical product development. Things that you touch, carry, and interact with. I spent 13 years at Nortel Networks with a 100-person team that designs next-generation communication products. Since then, I've gone on to Design First, a team of 20 industrial design engineers, product managers, and manufacturing setup specialists. And specific to IoT, products need to be easy to install, use, and maintain, and provide visible brand elements on both the hardware and now the software platforms together.
Hi, I'm Hugo Fiennes, co-founder and CEO of Electric Imp. My background is working on various consumer electronics products, MP3 players sort of a decade ago. Then the iPhone, first 4 generations of the iPhone, I worked on at Apple, worked on the Nest thermostat and various other bits, and now founded Electric Imp, which is a platform to build connected devices with.
Good day. I'm Oliver Hutaff. I'm the CFO at Electric Imp. My background is 20 years primarily in consumer electronics, both hardware and software. Hugo and I both were in the MP3 space about 15 years ago or so together. I've done a lot with connected hardware as well. I was CFO at Roku previously and have also worked in professional services as well.
Hi, I'm Geoff Parker. I've got about 20 years in software development, anywhere from kernel development right up through service, system integration, and really right up to the front end. I've worked in government, industry, enterprise, and startups.
And I'm, I guess, the host or the MC for today. I'm the Global Director of Engineering here at Macadamian. I've been doing this for around 15 years of my life, predominantly software. But I do have a background in robotics, and I focus a lot on internet-based technologies and large scaling systems. Macadamian has around 150 engineers worldwide and around 200+ people internationally. So just a quick overview of what we're going to chat about today. We're going to talk about the concept of design, especially around IoT, but we're going to be a little bit more techy about it today. We're going to dig in from 2 levels of design. We're going to do low level, then high level, get into a conversation around connectivity, manufacturing, bite into the firmware, designing for the daily use, and then segue into cloud data and security, and then finally capping it all off with the idea of creating value with IoT. So with that said, I like to start most of my presentations with a little bit of reading. So if you're out there and you're looking at this right now, what I want you to take away from this slide and the point of this is that just because you build it doesn't mean people will come. You got to really think holistically around why you're building it and make really key, clear design decisions around what it is you're building and what value you're going to bring. And hopefully this webinar is going to help you segue into actually building something that won't wither in the sun. So design, I'm no designer, but I do have a background doing design. But I mean, everyone in IoT has to be a participant in design, from the glass to the cloud and everything in between. And we want to really get our teeth, we want to start off by digging our teeth into the low-level design. And, the panel here, we thought about it, and we think we're going to talk about 3 major topics. And I think we're going to start the conversation with Hugo. Hugo, I mean, you and I have chatted a little bit, and I know your company is completely centered around, selecting and providing a connectivity-based solution. Do you think you can give us your thoughts on some of the key issues concerning that connected, selecting your connectivity solution? I mean, we have so many options out there, from Bluetooth to 3G LTE to Wi-Fi. to just far out there RF. So if you could give us a couple of your insights into that, picking your connectivity, that'd be awesome.
I mean, some of the stuff on connectivity, it really depends on what you're making. If you're making something which is going to connect to a phone, it's a wearable, for example, never going to be more than 6 feet from a phone, then Bluetooth is the obvious choice, and Bluetooth LE is sort of the current best choice really there. It's limited in bandwidth, but for actually many of these things, it fits really well. Its power demands are really low, so it's very good for small batteries and small wearable devices. That's one area we don't help with that type of area, but that's an area that's completely valid and fits some categories of products. Kind of stepping up on that for slightly more global accessibility, you can have a Wi-Fi connected device, and these devices can connect very easily directly to the internet through existing infrastructure in people's homes and offices. The thing about a Wi-Fi connected device versus a Bluetooth connected one is it's available and online all the time, no matter where the user is. When the user is out of a home or an office, they can still, the device can still talk, and they can still monitor and control it from anywhere. Obviously going up from there, and it's still going up in cost as well as complexity and approvals and everything like that. You kind of get to cellular at the top end, which is great, works almost anywhere, is quite expensive, and has obviously issues with ongoing cost, as anyone with a cell phone knows. There are actually some really interesting new technologies in the middle there, which are trying to do wide range with sub-gigahertz. Things like Sigfox. It's pretty interesting. It's a very, very narrow product category though right now, and it suits certain applications perfectly and others not at all. But I could kind of go on forever on some of this, but I think that covers some of the the basic categories that people building products these days are looking at.
So there's a wide variety there. My personal opinion is that connectivity and what you pick really defines the context of use. Like, what are you going to do? Now I have to pair this with a phone, and my phone becomes the modem. Or it's able to be on a Wi-Fi network, but I have to deal with always connecting. If I want to bring it with me or take it to many places, attaching it to a network now becomes kind of that barrier of entry. And I know, Kevin, you've designed quite a few products that have multiple contexts beyond just from Wi-Fi to Bluetooth to NFC. Could you talk a little bit about some of that experience? Maybe specifically digging into like form factor or power.
First, I'll say I absolutely agree. That sort of first touch of the users is how to set up the product, and if you get that wrong, you set the whole out-of-box experience off. I mean, people do want experiences; they don't want devices. The tagline we used to use in the '90s was "People want toast, not toasters." A good physical device, and I live in the physical world, so a good physical device, you want to do three things. You don't want it to fail or break, you don't want it to get in the way of the experience, and you don't want it to be obsolete in a year. So maintenance and updating, and now the whole sort of connected to the world, updating without making your hardware obsolete has some challenges. In terms of what we do in the physical design space, we're looking for as many plug-and-play components as possible, third-party devices like the IMP. We're dealing with the housing, we're dealing with the electronics. The radio is the connectivity component, so the more that can be easy to integrate into the firmware, cost competitive, the more it minimizes on approval times for the radio itself through the FCC approvals, the emissions, the safety. That's all great in terms of moving to market quickly. And as well, once you get to the cloud, having that integration with a radio that is already connected to the cloud, the IMP team can talk a little bit about that.
Absolutely. But before we get IMP back on the line talking about connecting to the cloud, because that's going to be a little bit later in the webinar, I wanted to give the ball just to Geoff quickly to maybe give us a couple constraints around connectivity in the enterprise or even in health care. Are there concerns around the choice of connectivity when we start dealing with larger organizations or potentially behind giant iron curtains of the enterprise?
Yeah, definitely. There's challenges in terms of integrating into these environments. I mean, a lot of these places are fairly constrained or locked down in terms of what they want to allow on the network. So before you start building a device where you're thinking, oh yeah, we'll just plug this into a network, have some of those conversations with the people involved in those networks to make sure that, yes, they want this data into their network, and there's some kind of a plan there for how you're going to connect and share this information into those systems. And also keep in mind what kind of burden you might be introducing into these systems, particularly in the IT and support environments. People don't want to be overloading their IT departments any more than they already are, and a lot of the internet devices that we're looking at nowadays, there's some kind of a configuration component there. It's how do we get it onto the Wi-Fi network, or how are we provisioning it with different cellular cards and that kind of thing.
So, I'm going to agree with you again, Geoff. One of the big things I've seen is really they're trying to go, one of the major reasons I see a lot of enterprises going with IoT is that they're trying to actually reduce their cost of support. Get insight, be able to connect to a device, be able to get information from it, where typically there used to have to be a technician deployed or something along those lines, or some person with some type of techno-savviness to be able to help deal with field support. But you also touched on an idea of devices, how they're going to connect it, approve things like that. And Hugo, we've talked before about this, is that whole idea of connectivity standards. And one of the biggest challenges there is getting a device onto a network, but there are a huge variety of standards. What's the benefit of going with a third-party provider versus baking my own Broadcom soldered onto a circuit board?
The main thing with doing it yourself, and there's lots of people who can assist you along the way. As you said, say Broadcom have some parts and they give you some software. Is that anything you do there is your problem from then onwards? You've now built yourself a custom solution, and then you're going to have to support it for the life of the product, which could be a decade for certain infrastructure type products. Also, you'll find that most of the things, if you're getting free software from a chip company, it's designed to sell chips, and their helpfulness ends once you've bought the chip and got it connected to, say, local Wi-Fi. You're connecting to the internet, which is actually quite different from connecting to local Wi-Fi in terms of the problems you have to deal with, and obviously server-side and scalability and stuff. All of that isn't included. That's not their problem. When you look at chip companies, they will give you software, no matter what the chip company is. The software is there as a marketing thing to sell chips versus another chip vendor. So just bear that in mind when you're looking at solutions. When you pick a platform solution, say our platform, what we're trying to do as value is provide a secure, long-lived, easy-to-maintain connection to the internet, so your data and application can just work seamlessly. And that is actually our stated aim, and that's what we do. So it's different. There are different ways of approaching the problem. And you really have to look at it holistically and look at all of the parts that you're going to need to ship a product, not just connect a device, because shipping the product is the much harder bar, a much higher bar beyond just connecting something.
So I'm going to push us along here. We have so much. We could talk the entire time today on any one of these topics. So I'm going to push us along to the next phase of this webinar, where I really want to start giving people some insight into something that I think, when we're working with some of our customers, they really understand this space already because they're already in the manufacturing and they get things built, or they subcontract to manufacturers already, or they don't. And in the event that they don't, and they've never gone around to building a custom product, they don't know anything about the manufacturing, there's a lot of ignorance here. And it's just because it's a completely different world for a lot of maybe technology companies that are maybe traditionally software, or maybe even traditionally non-software, or even non-high technology companies. Kevin, you've been in this space for a really long time. Like you said, 30 years. Can you give us some tips and tricks for working with manufacturers, maybe even some of the suggestions you can make on how to pick a good partner?
Sure, absolutely. The strategic design team has to figure out what innovative new features, functions they're bringing to market. The role of the manufacturers to help facilitate that. On my experience is strictly on the physical product side. So there's a process that goes on from the concepts and the demonstration units that get built into the detailed design, the user interface and engineering, into the alpha production intent prototypes, where we actually are trying out the products in the market with testing and refinement, sort of user trials prior to full production. It's really important that because the hardware development, it takes a long time from the point where we actually say, let's try this, to the point where we're actually building physical components. So getting a lot of the simulation done up front and the experimentation done is important, so that a turn cycle in software may be a month or so. A turn cycle in a hardware development might be 3 to 4 months, and quite a bit more costly in terms of what you have to throw out if you don't get the process right. Moving on to field trials, then obviously general availability is a well-scheduled and an ugly place where you can spend a lot of money if you do it wrong.
So just a quick follow-up question around that. What's the typical timeline for people maybe entering into the space for the first time or maybe even the second time to get that original prototype to mass production?
The fastest products, if we're talking about, let's say, an IoT sensor product, the fastest is 3 to 4 months is the full development cycle, including the build-out of the first prototypes and the evaluation, and then another 4 months typically from the point of time where you're moving to, you're moving to tooling and production, and a 4-month cycle gets you into early pilot builds and general availability.
So 8 months end to end is probably the fastest
Yeah.
you can turn that around?
That's of a product of any complexity. I'm not talking about incremental changes to existing products.
So we're talking, manufacturing is sort of this hidden cost for a lot of people as well. Oliver, you've been in the space where concrete products had to be manufactured and shipped and mass produced. Can you give any advice to what to worry about when you're picking a manufacturing partner?
Yeah, I mean, I think certainly there are some, there's just some high-level things around picking a partner who is familiar with the technology that you're deploying and making sure that they have experience in, both the device and the technology platform that you're utilizing. Typically trying to have a manufacturer, bring up a new technology for you, generally that will cost you some cycle time and some efficiency. I think if you're thinking about it from a manufacturer's point of view in terms of how they manufacture, you need to think about the total offering that you have, not just on the hardware side, but also on the service side and the life cycle of that device. Typically manufacturing companies that build physical products, particularly in the consumer space, they're very, very margin sensitive, and so everything is about BOM cost. In a connected product, the right answer may be to not minimize the BOM cost, but go for the right solution that is going to be able to be scalable and robust and secure out in the field, even if you pay a premium for that up front to a slight extent. So I think picking the right partner and making sure you are looking at the total life cycle of the product that you're building and what it has to do, and then costing it and figuring out the right economics for it would be the two things I would encourage people to really have a pretty good handle on.
If I could add to that, it's Kevin Bailey. If I could add to that, the manufacturing partners really just want to manufacture. They will help you as much as they can, but if you go in with an organized product file where you've done the development and you've worked through product and manufacturing issues, you can have a very clean experience in terms of moving into manufacturing. The larger manufacturers that deal with us actually enjoy the fact that we bring in a lot of the confusion that they really don't want and get them into manufacturing quickly.
Really interesting conversation here. One thing that I've always found when I first started getting into IoT around a year ago, one of the things that was really confusing for me, and it came up over and over again, was this concept of emissions. Now, I'm gonna pass the buck over to Hugo for a second, and could you quickly explain to us the idea of emissions and what that means?
I mean, emissions is part of the issue to do with approvals. Essentially, that when you ship a product, there are certain government regulations in each country you might ship into about what emissions of what electromagnetic emissions a device can emit and still be shippable. So there are limits for these in different frequency bands. There's also susceptibility, which is about things like ESD. So they basically take several thousand volts and zap your product, and it can stop working. You can define that as being an acceptable past. If it goes up in smoke, then they tend to fail you on that. But if it just stops working, you can say that's acceptable. But then you have to think, okay, if someone in a very dry bit of the country scuffs along their nylon carpet and touches my product and it becomes a return, maybe I should make my product more robust against that. But I mean, that's the susceptibility. But on emissions, connected products which use radios, this becomes a lot more complex. It used to be just a non-connected product. There are certain emission limits, but you're not trying to emit anything. So it was kind of fine. There were certain design techniques you'd use to make your product electrically quiet. You take it to a lab, get some testing done, get a certificate, and ship it. With connected products, it's now a lot harder because of the fact that you have to actually prove the device, when it's transmitting, conforms to other regulations for intentional emitters. So that's actually a pretty deep area. You can accelerate that a lot by using pre-approved modules, which will have something called modular approval, especially in the US and Canada. Modular approval is not worldwide, but there are certain jurisdictions this works in. A modular approval lets the person supplying the component provide most of the testing, and then your test house just references that, which saves you a lot of money, a lot of time, and a lot of specialist knowledge that you might otherwise need. But there are always exceptions to this, and there's a lot of depth there. It's actually something we should probably put more stuff on our website. We have stuff on our website about testing procedures about this, but it's a very, very deep area, and that's something you have to look out for, because you cannot legally ship something without these approvals. So just because your product works doesn't mean you can ship it. It has to work and be legally approved.
So Kevin and I have actually gone through that exercise together, where we started evaluating a chip with having to build a custom antenna versus a component manufacturer. And I think you bring up a really good reason to take a strongly consider a component like the electric amp or maybe some of your competition perhaps over trying to bake it yourself. And I know there's a tendency to want to build something from scratch and fully control it. But in this particular case, emissions can be, Kevin, I think I can quote you in saying that if you do it wrong and you get to the emissions phase and you fail miserably, and the acceptance phase, that might take you back to the drawing board. Is there a way to de-risk this during the prototyping phase?
Absolutely.
So that question's for Kevin.
Yeah, absolutely. It's Kevin. Those prototypes have to be fully functional, and you have to be thinking about the physics and the engineering around the radio and the radio emissions, so that when you get to testing, it's already a low-risk element, and that's important to do carefully at the early stage, and not just wait until you've configured everything, only to find out that your product size has to change, the interface has to change. You just don't want to be doing that at the end of a cycle.
And bear in mind that there's a lot of people go, well, I want the chip myself and put it on the board because it'll be cheaper. That doesn't actually always hold true. Things like a lot of the chips these days are designed for mobile phones. They're incredibly small, and it's very small, like ball pitch on a silicon. And that means that if you had to build your whole board, in your entire product board, at a technology level capable of accepting these tiny chips, you've made your board several times more expensive. Whereas people who, if you buy a module, the module itself is built with the very high-tech PCB technology to be able to accept these chips and with impedance control and all the stuff you need, and that actually then minimizes the cost. And to the point of, if you buy an iPhone has a Wi-Fi module in it. Apple didn't put the Wi-Fi chips on the board, even though they're making hundreds of millions, because actually it wasn't cost-effective to do it that way. It was better to use a module. So modules are not just the sort of the domain of the lazy design engineer. They're there for a reason. There's really good, solid reasons why people use modules, and you should definitely investigate that instead of just defaulting to, well, the chip is going to be cheaper. There's a reason modules exist, and they're built by specialist RF companies.
That makes a lot of sense. It's Kevin. Could I just say one more thing? It's Kevin. That makes a lot of sense, and that modularity really helps in terms of thinking about where you want to take risks. There's a whole bunch of risk in a new product development, so minimize the risks across the board if it's not critical to the experience and the time to market. And a modular radio is just one of those elements that has a significant amount of risk around it that you want to help yourself if your cost targets can be maintained. And IMP, as it was mentioned, just because it's a component, it's an overall cost that may not be an issue.
So I'm going to push this along. We still have quite a few things to talk about, and manufacturing. We could like connectivity and choosing the right manufacturing components and designing those low-level components can be a webinar unto itself for a couple hours. But I'm going to progress forward to firmware. This is the land of the embedded developer, and in my personal opinion, it's becoming less and less firm. And Hugo, you've built a solution with your team at Electric Imp that has sort of facilitated the idea that I can actually download my firmware from the cloud. what was your reasoning behind sort of that cloud-attached firmware? And could you give us a little bit of a story there as to like what you thought that was what value that was bringing to developers?
Yeah, I mean, I just at the beginning to say that OTA, over-the-air firmware updates are not actually a new thing. Obviously, they exist in lots of places. But one of the things that we did with our platform that is actually pretty unique is the fact that we separated the operating system and the application, even on a tiny embedded device that's the size of your fingernail. The reasoning for that is because people building devices, when you had non-connected devices, you could do the build, ship, and forget. Once the thing is done and tested, you ship it out, and you only ever see it again if it's a warranty return. That doesn't work for connected devices where security issues shift around, and obviously you may need security updates in the lifetime of the product. So separating the operating system and the application, both of which can be updated over the air, means that on the IMP product at least, we manage the security of the firmware at the actual OS level ourselves, which means it basically absolves the users from the responsibility of doing security maintenance. They still can update their application, add features, fix bugs, all that stuff, also over the air. But one of the things they don't have to do is sit on the security mailing lists looking for new disclosures and working out whether their product is affected by that, because security is maintained as a service. But yeah, generally on connected devices, OTA firmware updates and secure OTA firmware updates are an absolutely essential part. And I do talks at various security conferences about this, in that when you're making a connected product, you need to think about security from the very beginning, because if you don't have that right, if you have your secure update strategy right, you can fix most problems in the field if they occur. If you don't have that right, then you're kind of sunk. Recalling devices to update the firmware is no longer an acceptable strategy if it ever was, really.
So one thing that I've seen here is that this has sort of allowed for a slightly more rapid OTA release schedule. Instead of trying to be completely 100% correct, because Kevin, back in the day, the embedded environment was massively deterministic. You controlled your own destiny. You managed the hardware that was around you, and it never really changed. Today, we're going to be adding more and more applications to the particular platform, and we're going to want to be able to cycle fast, and we want to get to market quicker. We don't have 2 years to bake in a really comprehensive, complex firmware that just lives and breathes by itself. One thing I've noticed is that we're able to actually produce firmware updates a lot faster with technologies like the IMP. I know Spark has something similar as well. There are ways to be able to send updates from the cloud. But in your opinion, Kevin, you've lived through this evolution. What are you seeing at the firmware level, and the benefits of this evolution of cloud sort of attached firmware, or at least cloud deployable firmware for the OTA that the connected device brings?
Well, everything behind the radio is a custom piece of firmware as well in terms of what the device does. And in the hardware world, you kind of have to pick, unless it's a display-based element where you're really moving the interface through to that display, you're forced into buttons and controls that are fixed. And so there's only a limited amount of firmware update possible. But that's being pushed as well in terms of making downloading that firmware, updating that firmware, fixing bugs that until the product matures. But in the hardware world, a lot of times you have to go and make product 2. You can't just keep fixing product 1 unless it's a smartphone, which is a vehicle through to a display where we're back to a display-based interface.
I mean, there's stories around being able to update the firmware so that the rate that it updates information in the cloud saves battery. There's ways for you to potentially create updates that your first version wasn't quite as power, didn't have quite the same power profile that you really wanted. It was consuming a little bit too much battery. With a connected device, you have the opportunity to maybe make a couple changes to how fast it's cycling, how often it turns itself into sleep mode. Whereas before, you just sort of lived with it until you got to revision 2.
Right, because it wasn't thought about. It wasn't thought into the firmware. And as you say, sensors and algorithms that twist how we're going to actually collect data, how we're going to manipulate it prior to sending it to the cloud. As long as the design team can think about it, we can put hooks into the firmware and hooks even into some of the hardware to actually make a little bit more flexibility and longevity to the product.
All right, I'm gonna quickly progress here. We got around 10 more minutes before we want to start taking some questions. Actually, I've seen a couple that have just come over the air here. Is there a particular OS that industry is adopting for IT devices? Actually, I'm gonna send that towards Kevin. Kevin, are you seeing a particular operating system that people have been sort of leaning towards in the products you have, or is it still just sort of custom pick code, running kind of C code?
Absolutely custom pick code. I mean, really, there's an underlying, what's coming. There's way more data coming. There's this overload of how we're going to manage it all, and it's a new operating system required to push data back at us. But from a hardware and from an embedded device level, there's still a variety of choices on what people code, and especially in the cost-driven world where it's still chip level, it's still build out custom pieces of code.
So, I mean, I just add to that a little bit that I mean, the traditional embedded OS for connected devices has actually been Linux because it's free. It's the hardware that runs it is relatively cheap. It's just not suited to all applications, and as has been shown by many vendors, it can be quite hard to secure. I mean, by default, Linux is very secure, but the problem is that the implementations that people put on top of that have been often lacking. You see almost every router. I mean, the most common embedded connected device is people's Wi-Fi router, and that pretty much 100% of the time runs Linux these days, and there are issues. It's not Linux's problem, it's that Linux is a big thing, and people tend to pull a bit of thread and end up with the whole ball of twine.
So one of the ones that I've seen a fair amount when we start talking about that is Arch Linux, or some people even gone to RT Linux. And then you get into sort of the more industrial-based operating systems like VxWorks and along those lines. If you really need to get into that operating system level, if you're dealing with a lot of application and a lot of intelligence and scheduling, and depending on whether or not it has to be a real-time scheduler. But definitely seeing a lot of variances of Linux. And there's actually a couple really genius Linux kernel builders where they'll take something like I think it's an Arch Linux, where you can actually choose your hardware and you can sort of select it and build your own image and then be able to deploy it based on the modules you've selected for your hardware. With that said, we did have another question quickly around if you're shipping a product worldwide through Kickstarter, do regulation requirements still apply? My gut feeling there is that they do, but I'm going to throw that to Hugo and Kevin.
Absolutely, they do. Yeah, they absolutely apply. There are certain exemptions for like development boards and unhoused things, things used for product prototyping. If you're shipping, there's, for example, Chip Whisperer, I think is an interesting project which is on Kickstarter right now, and it's an FPGA board and it's a bare PCB, and that one you can say this is a development tool, but an actual product, no, you don't get any exceptions just because you're a small company, which is problematic, and you do need to think about that. Because if someone in Azerbaijan wants to give you some money for it, you're going to have to work out what Azerbaijani wireless regulations are, which is, that could cost you many thousands of dollars.
And in the medical space, even if at a prototype level, that you've got some sort of obligation to file an IRB and actually track and monitor what you're providing and what you're giving out. So there's a little more effort involved.
All right, I'm gonna push forward into sort of the higher level design. We're moving more and more into software now. We're getting away from that hardware, and I want to start thinking about contextual design. So this is where the user might start to interact with your product, and I want to start to change people's mindsets around. So we're talking about this in serial, but in reality, they go side by side. Every one of these steps is interconnected. Picking your radio. Your connectivity options will have a direct impact on the contextual design and limitations, and vice versa. You might design something that will affect your radio. So there we go. I want to put a picture in front of people right now to sort of think about what the context of daily use. And I'm stealing this from Kevin actually, where you have to design your solution around how it's going to be used. And in this particular case, the entire journey is going to get, as we go into the future, it's this idea that devices are going to be all around us. They're all going to be connected. They're all going to be gathering information. And when we get into that nice little building in the middle, it's got its own complete, unique constraints and limitations inside of it. But one thing that comes to mind right away around designing is that especially from a technical perspective, it starts making me think about platforms and standards. First, I'm gonna Geoff, what are your feelings right now on some of these standards that people are sort of throwing at, or platforms like ZB or Intel's backed, I think it's OIC, or even Qualcomm's backed Alljoin. These are all sort of standards for connectivity and broadcasting, so that inter-device sort of a parlay, so to speak. What are your thoughts right now on that in the enterprise?
So I think it's a little bit like the radio. I mean, there's a lot of these standards out there, and there's a lot of them, and they all have their own slightly different bent on what they're really trying to achieve. So, some are trying to create a nice, smooth way of connecting to the internet. Other ones are around being able to talk directly device to device, or being able to control things, creating mesh networks. So it's really around what are the kinds of properties that you're looking for your device, and how do you want to connect it to the rest of the world, and then finding the right sort of standard at the moment that sort of fits in with your design, and bearing in mind that a lot of these standards and things that are out there seem to still be in a bit of flux. They're establishing themselves. They're still trying to work out, where exactly they fit into the ecosystem, but it's really find the right one, use it, and then I would say try and, if you're connecting your system to the internet, connect it to the internet and move your data up to a stable layer, and use standard internet protocols sooner than later. It'll require less revision of the work that you've done as the standards still sort of adjust and change. So it just makes it a little bit easier into the future.
So I think you stole some words right out of Oliver's mouth there, because I think Oliver's got a pretty hard stance on the idea of standards right now. So, Oliver, if I'm going to ask you the same sort of question, what is your view on standards, enterprise or non-enterprise, but around those IoT standards that are evolving right now?
Yeah, no, I think it's a great question. I think if you've got a specific use case that you're trying to solve, and it's fairly limited and closed, the economics of it, and you're looking to just simply solve that one issue, going with a standard that basically gives you a closed system certainly can work for you. And in the enterprise space, a lot of the value proposition for them are around identified benefits they're looking to get right now. As you get a little more into the consumer space, what we see with a lot of our customers is they come in with the idea of an offering to a consumer that's based on utility or features to the end consumer. And the business model starts to form after that as they start to bring in more customers, as they see what the data they're getting off of their devices are, and then how they can monetize that. So for use cases that either need some upside or have potential upside once they're deployed, I think keeping as much flexibility as you can, and I think using the internet protocols, open APIs, is really the way to do that and not to get locked into anything. So I think in terms of evolving business models in a very, very early space for the IoT, the more flexibility you can have is certainly worth the investment to architect your design in such a fashion.
All right, so we're getting close to time here. I was hoping we were going to get some questions right now. So I'm gonna barrel through here. I agree 100%. I think that the standards right now are a little too haphazard, a little bit all over the place, and haven't really gelled yet. And I like that idea that both you and Geoff are sort of saying perhaps we go back to some of the older standards for ways to do inter-device communication and also for that longevity. The other side of it is like talking about longevity, Kevin. You have to design your device for today, but you also have to design your device for like its entire lifetime. What are some of the challenges around designing for its lifetime, and what have you seen maybe over the last 2 or 3 years as the evolution of internet-attached devices?
Well, with the massive amount of data coming, really from a user's perspective, we're going away from an operating system where operating implies sort of active management to an interaction system where, as a user, I want my devices or my world around me, I don't want to think about them as devices anymore. They're just going to be things out there that bring and collect information that's important to me, delivered in a form that I want on the particular device or in a situation that's appropriate and that I'm currently engaged in. And in many cases, don't deliver it, manage it, the routine stuff for me. If it's a furnace, manage the furnace for me, call the repairman, get this thing sorted out. I don't want to manage it. We got so much coming. We really don't want this massive operating system because it implies I have to operate it.
All right, so I'm gonna move on quickly. We're gonna get to the next one, which is the whole idea of the customer journey. I think we would be negligent in not encouraging everyone to think about the entire journey, enterprise or customer, where you think about exactly what Kevin was just explaining. There's an entire journey that's its lifetime. It's also the entire journey of like every single day and how and where you're going to bring your device, what devices it's going to talk to. And it's also pretty specific to, if you think about the entire journey, so from the moment it comes out of the box to the moment it goes into the garbage, or recycling, let's hope recycling, then you're going to be able to then make those really smart decisions about those other points we've been talking about today. That's that radio, that's that standard. What particular standard are you going to use? Does it have to comply to something that's an enterprise-based standard? What's your modules? What's your low-level design? What OS you want? But I'm going to push through quickly to the last slide here because I think there's a really so the last slide of these sort of a little bit more like the technical discussion around design, and it's not an Internet of Thing without connectivity to the internet and what we sometimes refer to as the cloud. So it's talking to other things using some type of internet-based backplane. There's going to be 50 billion devices in the world in 5 years that are IoT devices, so internet-attached sensors and whatever. So Oliver, I wanted to ask you this question because this is a question I ask a lot of people when I'm trying to work with them on a solution: is do they want to be in the business of data? And what I mean by that is, if we look at the recent compromises that have happened with companies like Target and Sony, information on a server will be compromised. You can spend billions of dollars to try to lock it down like Fort Knox, but it will still be compromised. And there's all sorts of ways to make that compromise happen. Oliver, in your opinion, as someone who looks at the overall return on investment, I think this is a really important question for people to understand: is should they be in the data business? What do you think?
Well, I think it depends on the individual customer to a large extent, but typically for most of the people that we're dealing with, the value around data is not necessarily in them being in the data business, but them finding out the utility of the data. And so using third-party data storage firms, data analytics firms, that typically tends to result in the best value for them because what they're trying to do is drive value through their business, and unless their business is around data storage, what they're looking for is actionable insights from the data or being able to use that data and what you can glean from it in terms of creating ecosystems of partners that are going to support their devices in the field or their customers. So I agree with everything around the questions around security and risk around storing your own data and being in the data business for the data itself. I think the better answer for that for most customers is figure out how to get the best utility and value out of your data. But I think relying on the larger third parties where it is their domain expertise around data security is probably a better answer for most customers unless there is something incredibly strategic about them maintaining control of their data.
So what I take away from that as like an engineer who thinks about internet attached systems is that we got to look at it maybe as a way, like kind of like you no longer spin up your own servers in a rack and attach some fiber optics to the back of it and buy a big, a big data connection to some giant ISV. Now you spin up your VMs with, platforms. You're going to spin it up with Microsoft or Google or Amazon or all the second and third tier versions of those, and you're sort of offsetting that expertise of understanding like the bandwidth and hardware and routing, and you're downloading an application onto it. So that way, you no longer have to take the capital, the capital expense of buying all this hardware and maintaining that hardware. It's just baked into that monthly cost. I kind of feel like data has to be something similar. You got to find that compromise between what do you want to retain and what should you stay away from. With that in mind, Geoff, I know this is a extremely sensitive topic, especially in healthcare, around where data and connectivity. can you give us some quick, since we're getting pretty close on out of time, any sort of tips or commentary about what the different lens that the enterprise brings when it comes to connectivity and data?
Yeah, so I mean, certainly within the healthcare, I mean, a lot of it is around security, protected health information, and managing that information securely, but it's also about making sure the data gets to the right destination. I mean, just because we've got a device and we're getting data out of it doesn't mean to say that it's actually going to somebody who can action upon it, who can make a decision to say, okay, yes, this is something that I want. And most of the people don't want large amounts of data coming at them. Once you do get it out to the end user, they want something that is the digest of the data. So they want something that says, okay, we've already done some analysis of this, and we only want to interrupt somebody and show it to them when there's actually something that's important and relevant for them to take action upon. So it's not just putting a big giant dump in front of somebody and saying, okay, well, now you figure it out. It's having the data there so that somebody can refer back to it, but then also being able to say, now is the time when you should go and look at that data.
Okay, so intelligence and transformation are really important there, and then the aggregation of that data. That's what I took away there.
Yeah, that's right.
All right, so that brings us to sort of the last thing. So with all that in mind, you've made the decision, you're going to make the investment, you're going to build an Internet of Thing. Ultimately, your business case is incomplete without a really clear identification, or without clearly identifying or articulating the business value. And I mean, Oliver, this is where you live and breathe. Could you walk us through the idea of how someone might be able to articulate the creation of business value? Maybe start with the idea that the consumer space, and then maybe how that segues to the enterprise space.
Yeah, no, I think it's a great question. I think it's something that has gotten less attention than it deserves, which is not unusual early in a space that's defined by emerging technology. If you think about it in the consumer space, typically consumer products tend to adopt new technology more around a feature set and market it on features. So instead of I'm changing the fundamental value proposition for the devices I'm already selling, it's I'm going to adopt more features and I can sell 10 or 20% more widgets than I have been previously. What we're seeing with a lot of our customers is they're designing based on utility for the consumer or perceived notion of convenience or some sort of perceived value from the consumer standpoint. The economics for that can be built in over time. We have a customer who builds a very simple, very elegantly designed handheld barcode reader that they can scan things that come out of their refrigerator when they're done, and it creates a virtual shopping list in the cloud. It was originally sold based on a convenience feature for the consumer. What they've done since then is partner with grocery chains in the UK and in France to do back-end fulfillment of their shopping lists that get created. And so while you can imagine what the economics would look like that, because they now own a consumer in their shopping list, it's a question about who would like to fulfill that for them. So they've added value after the fact, which is the right thing for their business model. It also provides greater utility for the consumer. If you take it a step further, it's not unreasonable to think that if I am a manufacturer of a competitive product that's on someone's shopping list, I'd love to have the ability to send them a targeted promotional coupon or something for buy one get one free, try ours for 50% off, whatever it may be. So you can see how there's value that can be created over having that data long after the device is out in someone's hands. So that's sort of a pure consumer play on that. If you think of it moving into the enterprise, enterprises typically are looking for more value creation right out of the gate. With a lot of the industrial customers that we have, there's a certain ROI that they have to achieve, either in terms of reducing cost, reducing channel partners where they're going to be able to now go direct to consumer and cutting out some of the middlemen out of the equation. But they're looking for a business case that is justifiable and defensible, based at the time they rolled them out. Now, there's still those opportunities to bring in additional channel partners after the fact, but with consumer, they're a little bit more willing to, say the market will mature and we will find economics as we go. In the industrial space, you really have to have a core value proposition that covers the ROI out of the gate. In both cases, obviously, what you're able to add on to that after the fact certainly is additional value creation. but that's how the spread that we see between consumer and industrial works. One of the other common things that we've seen is typically when our customers come to us, they're thinking about it in not a closed point of view, but in a narrower point of view around how they view their devices and their customers. What we've seen is there are any number of opportunities to bring in additional channel partners, whether it's direct channel partners like the firms that are fulfilling the shopping lists in the UK and France, or whether it's global insurance carriers who are looking at a home and say, I want to know about all the connected devices you have in your home, because if you have devices that are connected and that reduces the risk profile, we would be willing to put together an offering for homeowners insurance, for example, that will take into consideration that this is a lower risk home because of the connectivity features of the devices they may have in their home. So there's any number of opportunities to create value. After you've got devices in the field using the data, consumers are a little bit more willing to be leaning forward on their skis and take a leap of faith on that. In the commercial and industrial, it's really about you've got to have a core case that gets you in, that enables an enterprise to be able to go forward on that just based on the initial economics with it.
So Oliver, one of the things that I've also heard, especially when we're dealing with more conventional organizations that may deal with they have they have distributors. Those distributors will resell their solution to end consumers. Now those consumers may be other businesses, but there's usually a little bit of distance from the end user of their product. One thing that I think that is also part of value creation for both B2C and B2B is that idea of creating a shortcut, like you've almost short-circuited the end user to the originating organization. And have you seen organizations like almost go whole hog the minute you can say, well, do you want to own your users or have access directly, a direct channel perhaps you could say, to your end users? Is that something that it would be considered in the sort of the IIR of a IoT solution?
Absolutely, and the ability for a device manufacturer, I think as Hugo said earlier, typically for non-connected devices they sort of ship it and forget it. To now know your customer in terms of everything they do on a daily basis in terms of your device out in the field, you get incredible benefit of that just from a product marketing standpoint. You know what features they're using, you know what they're not using. You get much better at knowing your product, but also you now have the relationship with the consumer for selling them consumables or replacement parts, where previously you may have had to go through an intermediary like a retail channel or something like that. The example that we love to give to people is if you have a refrigerator with a water dispenser in the door, I have the pain point of at least once a year my wife comes in, holds a filter up, looks at me, and I make my annual pilgrimage to Lowe's. If my refrigerator is connected, my device manufacturer can know that my filter has 10% left. Just charge a credit card that's on file for me and ship me a new one without me having to do anything. So they've cut out a middle channel in that equation, but they also have direct visibility into how their device is performing in my home and how I'm using it on a daily basis.
I think the same analogy applies to field agents and people out in the field who need to be able to have information gathering, or not even people. It could just be sensors out in the field that are gathering information so you can deploy your field agents effectively. With that said, we have around 2 minutes left. We have 2 questions on the board. If anyone else has some questions, let me know. I'm going to read off those questions, but I wanted to say thank you. Thank you for listening. Thank you for being part of the webinar today. It was a pleasure. We had some great partners in Macadamian today on the air, and I learned a couple things. I hope you did too. With that in mind, we have a question around, I think this is to the Electric Imp team, which is the company that owns the shopping list in the UK? So when you're talking about that shopping list product, there's one question around who owns it. I'm not sure if you're allowed to share that information, but Oliver?
The shopping list would be owned,
That's a tough question. All right, next question.
It depends on the partner's relationship,
yeah,
and so on. And so that's one of the things which is, that's down to the business. They will make their partnerships, and they know where the value is, and their partners obviously know where the value is, and the list may be more valuable to some partners than others.
So just to clarify, we don't own the data for any of our customers. That is a decision between our customer manufacturer and their customers. We stay out of that equation.
All right. So the next question was, because we're pretty much out of time, is, do we have any ratings? I'm assuming this means, do we have any ratings on secure IoT OSs? You know, QNX, Linux, you know, VxWorks. I'm assuming ratings might be, do we have any feelings or thoughts around those operating systems? Hugo, Geoff, Kevin?
There's almost anything can be secure. It has, you know, there's no such thing as an intrinsically, well, probably are intrinsically insecure operating systems, but none of the ones you will have heard of generally are intrinsically insecure. But when you're doing security, it is all the way from the chips, the hardware, you know, secure trusted boot, how encryption keys are provisioned, you know, how firmware updates are delivered. It's a very, very deep stack there. So when you pick your operating system, it's not really the operating system, it is the implementation that affects the security. And so, you know, you can pick secure things that have been designed to be secure from the ground up, and if you pick an entire platform, that's an implementation of an operating system with sort of security guarantees on it, for example. But that's
and just to make things more complicated.
Answer in one sentence.
Yeah, absolutely. And to make it more complicated, you're adding more and more vulnerabilities with every degree that you add to the solution. The minute it's internet attached and a part of your application is running in the cloud and there's information there and there's accessibility to that information from applications and there's APIs wrapped around it and you have, you know, and you have applications running inside a cloud VM, all those are introducing the potential for vulnerabilities. So it's no longer just about the OS running at the firmware, it's about the entire solution, and security has to be a thought, like has to be baked in as a part of your design. We should have probably had it as one of the line items here. It's that important. All right, I'm not seeing any more questions. We're out of time. Thank you, guys. I had a great time today, and I hope everyone enjoyed this webinar.
Thanks, Tony.
Thanks to everyone. Thanks, Tony.
Thank you.